Hello everyone, I'm back. We left off right here on the bottom of page 2, and it says, after you have verified that the two criteria have been met, so once you prove that NP is greater than or equal to 5 and NQ is greater than or equal to 5, and you find the mean and the standard deviation, the next step is to find something called the continuity correction. So what in the heck is a continuity correction? A binomial distribution is discrete. It's a whole number. Whereas a normal distribution is continuous. It's made up of decimals. So how do we convert from one to the other? How do we turn this into this? The answer is called the continuity correction. So what we're going to do is we're going to take our whole number and we're going to turn it into decimals by adding and subtracting 0.5. So the continuity correction is the formula that converts a binomial distribution to a normal distribution. And the formula is plus or minus 0.5. So let's turn the page and let's practice some continuity correction problems. Use a continuity correction to convert each binomial probability to a normal distribution probability. So the probability of getting at least 158 successes. So what we're going to do is we're going to draw a normal curve because we're turning binomial into normal. So you're going to draw a curve. And in that curve, you're going to put a bar. And your binomial distribution goes inside the bar, which is 158. So whatever that number is, it goes inside the bar. Now, you need to turn that 158 that was a binomial into a normal, and we do that by adding and subtracting 0.5. 158 plus 0.5 is 158.5. 158 minus 0.5 is 157.5. Now, we're still not done. I want the probability of getting at least 158. So if I want at least 158 pieces of candy, I want 158 or more. Think of another example. You're riding the train and you need to borrow some money, and you go up to your friend and you say, man, help me out. I need at least $5 to get on the train. So you need $5 or more. So you want at least 158 successes means you want 158 or more. So you're going to shade this section right there. Now, looking at that, what you do next is you look at the bottom. So what you're really finding is the probability that X is greater than 157.5. And that's how you turn a binomial probability into a normal distribution. So you're going to use these numbers down here based on your shading to determine what you're finding the probability of. The probability of getting fewer than 63. All right, so let's draw our bell, make a bar, and inside the bar goes the number 63. Then you're going to add and subtract 0.5. So if I add 0.5, I get 63.5. If I subtract 0.5, I get 62.5, and I want fewer than 63. I want fewer than 63 pieces of candy. It doesn't say 63 or fewer, it says fewer than 63. So if I want fewer than 63, I don't want 63, I want everything less than it. So this is the probability that X is less than 62.5, and there's your answer, because you look down here at the decimals at the bottom and it's less than the 62.5. Let's try the next one. The probability of getting between 270 and 310 successes inclusive. So we're going to include 270 and we're going to include 310. This is a hard one. You need to make a bell. But now you have two bars. You have a bar of 270 inside, and you need a bar with 310 inside. So if I add and subtract 0.5 from here, I get 269.5, 270.5. If I subtract 0.5 from 310, I get 309.5, and I get 310.5, and that's how you do the bottom. Now, you want between 270 and 310. So I want between 270 and 310, but it says inclusive. Inclusive means include the 270 and include the 310. So this is a betweener problem that we learned in 5.1. It's everything between this bar and this bar, which is 269.5, 310.5. I put an X in the middle because it's shaded in the middle, and I always use less thans, and there's your answer to letter C. Let's try another one. Draw a bell, put a bar, and now you want the probability of getting at most 54 successes. So you're going to put 54 in the middle. You add and subtract 0.5 to get your bottom number. So that's 53.5 and 54.5. Next thing you do is you want the probability of getting at most 54. The most you want is 54. You don't want anything more than 54, but you'll take 54. The most you'll take of success is 54. So it's going to go from here all the way down because that's the most you want. You don't want anything more. So this is the probability that, since it's shaded to the left, you're going to say less than 54.5. And there's your answer to letter D. One more on this page. Find the probability of getting between 57 and 83 successes inclusive. So I want to include the 83 and I want to include the 57. So let's draw a bell. But you have two numbers, so you need two bars. You got a 57 and you got an 83. If you add and subtract 0.5 to get your bottom numbers, 57 minus 0.5 is 56.5. This is 57.5. This is 82.5. And this is 83.5. Now it says that you want the probability of getting between 57 and 83. So there's my between 57 and 83. But it says the words inclusive, so we're going to include the 57. We're going to include the 83. So it's really going from here to here, and it's shaded in between, so it's a betweener problem. 56.5, 83.5, X is in the middle because it's shaded in the middle, and we always use less thans, and there's that page. Now, I think we're ready to put all this work together into one problem. Here we go. So, putting it all together, the process. I'm going to move my paper up a little bit. I hope that helps. Step 1, verify the two criteria of NP greater than or equal to 5 and NQ greater than or equal to 5. If both of these criteria are met, then you're going to find the mean and the standard deviation. The mean is equal to NP and the standard deviation is equal to the square root of NPQ. After you do that step, then you're going to draw a curve, your little bell curve from the previous page, and you're going to add and subtract 0.5. Then you're going to shade the corresponding area under the curve. And then you're going to write your probability in parentheses. And then you're going to use normal CDF, just like we did in 5.1, to get our final answer. So let's put all this together. In a survey of heavy media users in the United States, ages 8 to 18, 47% said they get fair or poor grades C and below. You randomly select 45 heavy media users in the United States, ages 8 to 18, and ask them whether they get fair or poor grades. What is the probability that fewer than 20 of them respond to yes? All right, so here we go. Now, a lot of people get confused because they see the 45 and they see the 20. The N, the sample size, is always the bigger number, so the N is the 45. We don't need this this number until the end of our problem. So here we go. Our N is 45, the bigger of the numbers, and our P is 47%. So let's do it. So NP greater than or equal to 5, NQ greater than or equal to 5. N is 45 times 0.47 greater than or equal to 5. So turn on our calculator. Let me hit clear. 45 times 0.47 is 21.15. Is 21.15 greater than or equal to 5? Yes, it is, so we can keep going. N is 45. How do I find Q? Remember that Q is equal to 1 minus the P. So 1 minus the P was 0.47. So 1 minus 0.47 is 0.53. Greater than or equal to 5. And 45 times 0.53 is 23.85, which is greater than or equal to 5, so I can do the problem. After you verify you can do the problem, mu is equal to NP, but you just found NP right above to be 21.15. And the standard deviation is equal to the square root of NPQ. And N is 45, P is 0.47, and we found Q to be 0.53. Now, since I'm continuing on, do not work this out. 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 I'll show you why. Our calculator is going to do it for us since we're going to continue on with the problem. All right, so I verified my criteria. I found the mean and the standard deviation. Now I need to apply the continuity correction. So then the next thing I'm going to do is draw my curve. And inside that curve goes what I'm solving for. What am I solving for? What is the probability that fewer than 20 of them? So my bar is going to be my 20. Then I apply the continuity correction of plus and minus 0.5. So that's going to be 19.5, and that's going to be a 20.5. So I applied the continuity correction of plus minus 0.5. Now I need to shade my area under the curve. What is the probability that fewer than 20, not 20 or fewer, fewer than 20? So there I'm going to shade. Now I'm ready to do P, since it's shaded to the left, X less than, and it's going up to the 19.5. And here we go. Is everybody okay to there? So now go to your calculator. We're going to go to normal. Now it says to use normal CDF. So you're going to go to second dister, number 2. My lower bound, since it's going to the left, is going all the way down here to negative infinity. Remember, you can't type negative infinity into your calculator, so you type in negative 999,999. My upper bound is 19.5 based on your shading. The mean you found right here to be 21.15. Now, watch how I'm going to type in the standard deviation. I'm going to type it in just like that. Do not solve this. So you're going to do second square root 45 times 0.47 times 0.53. Notice how I typed that in. Hit paste, hit enter, and the answer you should get on your calculator. We always go to 4 decimals, 1, 2, 3, 4. 5 or above, give that a shove. So that's going to be 0.3111. And there is your answer to the problem. And I'm going to stop there and start my next video.